இதோட பாட்டு என்னது? வச்சிருக்கோம். So those who are online are able to hear me? Those who are online, can you please respond? Are you able to hear me?
Yes, sir.
Those who are online, are you able to hear me? PPT எங்க இருக்கு? இங்க யாரும் ரெஸ்பாண்ட் பண்ண மாட்டாங்க. கரெக்டா தான் போயிருக்கா? Those who are online, are you able to hear me?
Hello, sir. Can you hear me?
யாரோ பேசிட்டு இருக்காங்க. மேடம் ஒரு நிமிஷம் இருக்கு. Can you respond now?
Am I heard, sir? Hello.
Yeah, respond now.
Hello. Hello.
Check. So can someone respond in the chat?
Sir, can you hear me?
You're able to hear me?
Yes, sir, we can hear you.
Okay. Okay. Your volume come here. So. Chitesh, can you talk now?
Sir, can you hear me now?
Yeah, fine.
Sir, school lo konjam work online lo நேர்ல வர.
Okay.
Sir, can you hear me? Hello.
Okay. Solution. Yeah. So since in the previous class we have completed this chapter, we'll do some problems from this chapter. Okay. So I've selected around 25 problems and we'll be doing some problems from this. Okay. Shall we get started? Yeah. So just a minute. Camera வேணும் பாருங்க. இதுல கேமரா வேலை செய்யல. இந்த எக்ஸ்டர்னல் கேமரா இருக்குல்ல, அது அங்கதான் இருக்கா? ஓகே. ஒரு ட்ரைபாட்ல வச்சிருக்கியா? Okay. Shall we get started? Yeah.
Yes.
So look at the first problem. Look at the first problem. It says a man of mass 70 kilograms stands on a weighing scale in a lift, which is moving upwards with a uniform acceleration of 5 meter per second square. What would be the reading on the scale? Okay. So what is happening? There is a man who's standing on a weighing machine, right? And the mass of this is 70 kilogram. Now what is happening? So when he's standing inside the lift starts moving upwards with a uniform acceleration of how much value? Uniform acceleration of 5 meter per second square. Right? It moves up with the speed of with an acceleration of 5 meters per second square. What would be the reading on the scale? Okay. So here, if you observe, right, I would like to tell you 3 points. See, suppose these kind of problems where the combination of weighing machine plus lift comes into picture, right? So where there is weighing machine plus lift that comes into picture. Yeah. So there are 3 things that you need to check. So if the lift is stationary or is it accelerating? So there is one more point also that you need to take into consideration, whether the lift is stationary or it is moving with uniform velocity. So if you observe, in the case of stationary or uniform velocity, what is the acceleration of the system? 0. Whereas when the lift itself is accelerating, acceleration is not equal to 0. When acceleration is not equal to 0, you have to use a method that I'm going to tell you. If the acceleration is going to be 0, it is going to be a different story. Okay. So now see, if the lift had been stationary, right? So this man is standing on a weighing machine and the weighing machine showing 70 kilogram. What would have been the weight of him? They ask, no, what would be the reading on the scale? So when they talk about the reading on the scale, it is going to show you mass, not the weight. What is it going to show? It is going to show the mass, but not the weight. Right. So how much would be the value? When it is stationary, it will still show 70. Okay. Whereas when it is moving with uniform velocity, then also it is going to show the same 70. But when it is accelerating, you need to look at the directions. If it is accelerating upwards, you need to bring the system to rest. How will you bring it to rest? By applying a force in the opposite direction. Okay. So this kind of a reference frame where the frame itself is accelerating is called as non-inertial frame. So understand this. What is it called as? It's called as non-inertial frame. What kind of a frame? A frame which is accelerating. A frame which is accelerating is said to be a non-inertial frame. So whenever they have given you the acceleration exactly in the opposite direction to which the system is accelerating, apply a force of how much value? You will apply a force of m into a, where m is going to be the mass that is present inside, that is 70, into acceleration is 5. Right. So what is the weight of this person? The weight of this person is 70 into 10. Mass is 70, but weight is 70 into 10 mg. Right. Now, if you observe this force which has been applied, so since I applied this, I'm using dotted lines. So this kind of a force which is applied to bring the system to rest is what is called as pseudo force. What is it called? It's called as pseudo force. And 70 into 5 plus 70 into 10 is going to be the weight that it is going to show. So how much is the value going to be? So 70 into 5 plus 70 into 10. How much is it? 1050. This is going to be 1050 Newton. But what is the scale going to show? It will show 1050 by 10 kilogram. So answer will be 105 kilogram. So let me repeat it again. It's very simple, okay? I told you the whole story, but to solve this problem, all that you need to do is only one step. Person is standing, there is a weighing scale. If the system is accelerating upwards, then the force should be taken in the downward direction, right? Of how much value will you take it in the downward direction? Mass that is present inside the lift into the acceleration of the lift. So what is that force called as, which you apply in the opposite direction, which is done by, that is called as pseudo force. After you apply that, add or subtract the original weight of the person to that. Okay. Now, if you see, actually the weight of the person is, the mass of the person is only 70 kilogram. But due to this acceleration of 5 meters per second square, it is showing a mass of 105 kilogram. Means it's showing an increased weight. If you see, no, have you ever observed, like in an exhibition or something, you go in a giant wheel? So tell me if you're able to recollect it. So that has two kinds of motion. If I take this to be the axis, downward motion and upward motion. So whenever you're coming in the downward motion, do you feel like you're flying or you feel heavy? When you come in the downward direction, you feel like you're flying, you feel lighter, no? Whereas when you're going in the upward direction, you're actually going to feel heavier. The same logic is applicable. Actually, original weight is 70 only. But when the giant wheel is going upwards, no, the actual weight appears like 105. So it appears to be heavier. Okay. Whereas if the same lift is accelerating in downward direction, what would have happened? You would have applied the pseudo force in which direction? In the upward direction. In the upward direction of how much value? 70 into 5. So what would have been the weight at mass at that time? First calculate the weight. So 700 minus 350. How much is it? 350. So when the lift is accelerating downward with an acceleration of 5 meters per second square, the mass of the reading would have been 35. It will show lesser value. Okay. So that's what the theory is. Just make a note of it. So this concept is called as apparent weight. Okay. So basically, what is a non-inertial frame? So frame which is accelerating. So when will you apply pseudo force? When you have frames which are accelerating. So what do you mean by accelerating? It should not be stationary or it should not move with uniform velocity. So anything other than that, it is a non-inertial rate. Okay, shall I proceed? So look at the second problem. If a cycle wheel of radius 4 meter completes 1 revolution in 2 seconds, then the acceleration of the cycle is. What are they saying? If a cycle wheel of radius 4 meter completes 1 revolution in 2 seconds, then the acceleration of the cycle is. So radius is 4 meter, 1 revolution in 2 seconds, right? 1 revolution means it is able to cover a distance of 2 pi r in 2 seconds, right? So what is going to be the acceleration? How to solve this? So whenever a particle is revolving in a circular path, last class we discussed, no, what is the centripetal acceleration? A is equal to v square divided by r. So, but what is v? V is the distance, that is 2 pi r divided by the time it takes to cover it, right? So this is v square, the whole divided by r. So 2 and 2 will get cancelled. This will be pi square r square divided by r and r will get cancelled. So pi square into what is the value of r? 4. So answer will be 4 pi square meter per second. Is the point clear? Yes. Shall I proceed? So third question is, a ball falls from 20-meter height on a floor and rebounds to 5 meter. Time of contact is 0.02 second. Find the acceleration during the impact. So for you to find the acceleration during the impact, what have they given you? They have given you the height from which the object is falling and the height to which the object has rebound. Am I right? So time of contact is 0.02 seconds. So acceleration, can I write it as v minus u divided by t? Right. Now, if you see, when you talk about this ball is going to hit the floor. So just before it hits the floor, it is going to have some velocity. So after it hit the floor, it is going to have some velocity, right? So what will happen is you need to calculate those values and then substitute it here, and time of impact will be 0.02 seconds. So what I'll do is, before hitting the floor, what would have been the velocity of it? For that, I'll apply the formula v square minus u square is equal to 2as for downward journey. Am I right? So v square is v square only, minus u square is, it is dropped from a height, 0 square is equal to 2 into what is the acceleration? So you can take downward to be positive in this case. So what is the acceleration? I'll take it as 10. And what is going to be the displacement? 20. So it has traveled through a distance of 20 meters. So this is for the downward journey. So how much will v square be equal to? V square is 400, which implies v will be equal to 20 meter per second. Okay. Similarly, for the upward journey, what will happen is if you apply v square minus u square is equal to 2as, v square is how much? So in the upward journey, v square will be 0. Why? Because after reaching the maximum height, it comes to rest. So 0 square minus, we need to find what is the initial velocity with which it raised. So u square is equal to 2 into, what is the acceleration? Minus 10 into, what is the displacement? 5. So 5 into 2, 10, 10 into 10 is 100. So u square will be 100, u will be equal to 10 meter per second. So what you need to do is take these two and apply it here. So 20 minus 10 is going to be 10 divided by 0.02, which will be equal to how much? 1000 divided by 2. I'll add 2 more zeros. So this is going to be 500. Is there an option? Correct only, no? What we did. So time of contact is 0.02 seconds. So all this happened within find the acceleration. The 500 is right. There is a mistake in the question, the options. Or 1 minute. 1 minute. I'm wrong actually. I'm wrong. I'll tell you. The correction is the correction is when the velocity was taken downwards, if you take it to be positive, upward you have to take it as negative. So the velocity with which it reached the ground is 20, minus is in the formula. The upward journey is minus 10, the whole divided by 0.02. So that will be 3000 by 2, or it is going to be 1500 meter per second square. So this will be the answer. Okay. Tomorrow is your projectile motion test. Tomorrow or Sunday? Sunday, no, tomorrow is complex. Okay. So for that, mostly, I'll tell you, I have asked 8 MCQs, 2 1-mark questions, 3 2 marks, 3 3 marks, and 2 5 marks, for which you mainly need to look at the notes that I have given. You have to go through the notes, your class notes. That will be sufficient. And you need to use some bit of your logic. It's not like directly I've given everything from the notes. You need to understand the logic and then you will be able to solve it. Is the point clear? Shall I proceed? You're done? Shall I proceed? Hmm. What concept is this problem based on? So the question says, a bullet of mass 10 gram is fired from a gun of mass 1 kilogram, right? So small m is for bullet, it is going to be 10 gram, and capital M is for the gun, which is going to be 1 kilogram. If the recoil velocity is 5 meters per second, the velocity of the muzzle is going to be. So if you see the recoil velocity of the gun, so recoil velocity means this is V, which is taken as 5 meter per second. Okay. Now the question is, what is going to be the velocity of the muzzle? So what is the answer? $500. Okay. First, can you tell me what is the concept on which this problem is based? Whenever you see the concept of gun and recoil, it is based on Newton's third law, but Newton's third law is also based on the concept of conservation of linear momentum. So it is based on the concept of conservation of linear momentum. Okay. The system is 0, whereas the final momentum of the system will be m into u, right? Plus capital M into V. Okay. So small m is 10 grams. So 10 into 10 power minus 3, right? Into u plus capital M is 1 into 5. So u will be equal to how much? Minus 5 divided by 10 into 10 power minus 3. So how much is that? It is going to be minus 500 meter per second. So what does the minus sign indicate here? That the velocity of the bullet and the recoil of the gun are in opposite direction. So whenever the bullet goes in the forward direction, the gun will get recoiled in the backward direction just to conserve the linear momentum. And that is what Newton's third law also states. What does it state? Every action has an equal and opposite reaction, right? Shall I proceed? So you can make a note of this. Gun and recoil, it is based on Newton's third law or conservation of linear momentum. Done? So inertia refers to resistance to change. That's it. It's not dullness, it's not ease of motion, or it is not flow motion. It is the resistance to change. Means if an object is at rest, it will continue to be at rest. If an object is in uniform motion, it will continue to be in uniform motion unless and until there is an external force applied on it. Right. Next. Let's try this. There is a particle of mass small m which is projected with a velocity v making an angle 45 degrees with the horizontal. When the particle lands on the level ground, the magnitude of its change in momentum will be. So if you observe, this is a problem which is a combination of projectile motion and Newton's law. So if there is an object which is projected with a speed v making an angle 45 degrees with the horizontal, then it is going to travel in this kind of a path and it will hit the ground. So this v can be resolved into two components as v cos 45 and v sin 45. Remember, if the air resistance is ignored, if the object has a vertical velocity of v sin 45 during the takeoff, During the landing also, it will have the same component of v sine 45, and horizontal velocity is fixed. For a projectile motion, horizontal velocity is always v cos theta. So it is going to be v cos 45 degrees. So if you read the question, they're clearly asking what is the magnitude of the change in its momentum. So when I talk about the change in momentum, delta px is going to take place and delta py is going to take place. What is the change in momentum along the x direction? X direction, the v cos 45 is remaining constant. So final velocity is v cos 45, initial velocity is v cos 45, and they both are in same direction. So what will happen is, it will be mv cos 45 minus mv cos 45, which will be a 0. Whereas, what about the value of delta py? Delta py will be m into v sine 45, right? Now what I'm doing is I'm taking the final as positive. So this v sine 45 is what I've written here, because always changes final minus initial. So mv sine 45 minus, since downward is considered to be positive, upward will be negative. So it will be minus mv sine 45, right? So what will happen? It will be 2 times mv sine 45. It will be 2 times mv into sine 45 is going to be root 2. Root 2 will cancel this. Root 2 times answer will be root 2 mv. Is that point clear? So it will be root 2 mv, which is taking place only along the y direction. Okay, just want to tell you one additional point. Listen to this carefully. For example, had delta px come out to be a non-zero value. What is it? Here it is 0. Okay, that is why I wrote an answer as root 2 mv. Had it come out, let's say, for example, this is only an extension, this is an example. Had delta px been, let's say, mv, for instance, okay, just assume it, okay, then the magnitude of the momentum will not be root 2 mv, rather it will be square root of mv square plus root 2 mv square. So it would have been root 3 mv. Is the point clear? So this is the meaning of magnitude. It will be root 3 mv. Okay. Done. Try this out. So what is the answer? They have given the formula also in the question itself. You will get 0 if you add them, but what have they given? Correct. Option B is correct. All that you need to do is m into v minus m into u. That's it. They have given clearly what is v and what is u. Mass is given 150. So seventh question is, a cricket ball of mass 150 gram has an initial velocity of u vector is equal to 3i cap plus 4j cap, and final velocity of v vector is equal to 3 minus of 3i cap plus 4j cap after being hit. The change in momentum, that is the final momentum minus the initial momentum in kilometers per second, is given us. Okay, it's very simple. So the change in momentum is equal to P final minus P initial. That is equal to m is written as it is m into v vector minus u vector, or it is m into, what is the value of v vector? Minus 3i cap minus 4j cap minus, what is u vector? 3i cap. So minus is there, so it will become minus 4j cap. Did you understand? So it is minus of this value, so minus 3i cap minus 4j cap. Right. So what is the value going to be? Mass is 150 grams, so 150 into 10 power minus 3 into minus 6i cap minus 8j cap. So 150 into 6 is 15 into 6 is 90. So 900. 900 into 10 power minus 3 will be 0.9. So minus is common. I'll take the minus outside. So minus 0.9 I cap plus 15 into 8 is 120. So 120 into 0. So 1200 into 10 power minus 3 will be 1.2. So plus 1.2 j cap, and the answer will be this. Clear with this? Done? Try this. So if you read this question, you should be able to understand what concept is it based on. Do it fast. So it is based on conservation of linear momentum. Apply that formula. Sum of the initial momentum is equal to sum of the final momentum. A gun fires a bullet of mass 50 grams with a velocity of 30 meters per second. Okay. Because of this, the gun is pushed back with a velocity of 1 meter per second. Find the mass of the gun. So what is the initial momentum of the system? Before firing, what was the momentum? The bullet was inside the gun. So bullet was at rest, gun was also at rest. So what is the initial momentum? 0. So 0 is equal to M into M is mass of the bullet is 50 grams. So 50 into 10 power minus 3 into what is the velocity? 30 plus mass of the gun into 1. Solve it, you will get the mass of the gun. So the eighth question says a gun fires a bullet of mass 50 gram. So mass of the gun is 50 into 10 power minus 3 kilogram. What is the initial velocity of the bullet? It is going to be 30 meter per second. Because of this, the gun is pushed back with a velocity of 1 meter per second. So what is going to be the mass of the gun? Right. So initial momentum of the system is 0. So 0 is equal to m into u. That is going to be 1500 into 10 power minus 3, which will be 1.5. So 1.5 plus capital M into 1. So capital M will be actually equal to, it will come out as minus 1.5 kilogram, but negative is not taken. The reason why, yes, thing is, when we say this is plus, no, we should have taken this as minus. So had you substituted minus here, like if you put minus here, you will get the value as plus, because mass can't be negative here. You understood why minus here? Because bullet is going in the forward direction, gun is going in the reverse direction. So mass will be equal to 1.5 kilogram, and this will be the answer. Right. Ninth one. If the normal force is doubled, then what will happen to the coefficient of friction? So F is equal to mu into N. So F is equal to mu into N. So mu will be equal to F divided by N. If the normal force is doubled, what will happen to the friction? Or what will happen to the coefficient of friction? Will become, what is the option? This one, huh? It will not be changed, because what did we say? Friction is directly proportional to the normal reaction. Meaning, as the normal reaction is going to increase, the amount of friction that is going to come into picture will also proportionally increase. So when you remove the proportionality symbol, you introduce this mu as a constant of proportionality. For a given floor, it's going to be a constant. No, why would it change? Right? So the answer is not changed. Is the point clear? Here with this. So 10th one, these are all theoretical problems. Like, look at them. So if three forces F1, F2, and F3 act on a particle, then in equilibrium, what will happen? If three forces F1, F2, and F3 are acting on a particle, then in equilibrium, what should happen? What do you mean by equilibrium? The system should not accelerate. So if it should not accelerate, then what should be the answer? So actually, to be more specific, no, F1 vector plus F2 vector plus F3 vector put together will be 0, because we don't know the directions of them. Actually, the option should have been in terms of vector quantities, but I hope you're able to understand that the sum of all the three force vectors will be equal to 0. And yeah, so I would like to just give a statement. You can have it in your mind. See, suppose the forces are like this. It is called F1, F2, and F3. It will be F1 vector, F2 vector, and F3 vector. No, the vector sum of all the forces written like this is a concept called as principle of superposition. You can just have this in your mind. Nobody will ask you, because we'll be saying about this in waves chapter. Okay. So it's called as principle of superposition. So that is a vector sum of all the forces is what is called as principle of superposition. Yeah. Clear with this? Right. So listen, next one is based on friction. A block of mass m slides down with a uniform speed on an inclined plane having an inclination theta. So first of all, we need to understand this word with uniform speed. What do they mean by that? Means the acceleration of the system is 0. Okay. So a block of mass m slides down with a uniform speed on an inclined plane having an inclination theta. If the coefficient of friction between the inclined plane and the block is mu, then the contact force between them is. So if there is a block like this of mass m, there is a frictional force acting in this direction. In this direction, what is the force acting? So when they say a block of mass m slides down an inclined plane with inclination theta, no, by default it is understood that the inclination is with the horizontal, not with the vertical. If it is with the vertical alone, they will mention it. So theta should be taken here. If theta is taken here, how much will this be? This will be, I'm sorry, wait. Correction. So this will be mg, this will be mg cos theta, this will be mg sin theta, right? Now, they're asking what is the contact force. You remember I told this word contact force once. What is it? It is actually the resultant between the normal and the frictional force. What is it? It is a resultant between the normal and the frictional force. So what is the value of frictional force here? Mg. Frictional force is mu times N. What is N equal to? Mg. N is mg cos theta. So frictional force will be equal to mu mg cos theta. Am I clear with this? Right. What is the normal force? Normal force will be mg cos theta. So what do you mean by contact force? So contact force is the resultant of the normal and the friction. So normal and friction are perpendicular to each other. So it will be square root of n square plus f square. This word I have given when I discuss the concept of angle of friction, go and check it. I asked you to write it also. In the angle of friction, that is for lambda. That one. This lambda. Okay, now make a note of it. That resultant force is there. No R we have written. That is what is called as the contact force. Okay, because the question is very clear. Calculate the contact force between them. Okay, having said that, it will be square root of n square means how much? M square, or it is mg cos theta, the whole square, plus what is the value of f square? It is mu mg cos theta, the whole square. So what will you take out as common? You take out mg cos theta outside. Actually, you take mg cos theta, the whole square outside. Under a root, it will come out as mg cos theta into what is that you're left out with? Root of 1 plus mu square. So if you observe, the option 4 is right. So mg cos theta into root of 1 plus mu square. Okay. Okay. Shall I proceed? Yeah, this is your NCERT problem. A monkey of mass 40 kilogram climbs on a rope which can stand at maximum tension of 600 Newton. What is the tension in the rope if the monkey climbs down with an acceleration of 4 meter per second square? So here there is a rope. There is tension. Right, there is tension. And this monkey is climbing up. The monkey is climbing up. Right. So what is the tension the rope can withstand? The maximum tension it can withstand is going to be 600 Newton. Right. That is the first part of the question. The second part, what are they asking? What would be the tension in the rope if the monkey climbs down with an acceleration of 4 meter per second square? So this is coming down with an acceleration of 4 meter per second square. So tension is going to act in the upward direction, right? What will be the expression you will frame? Mg is acting downwards. Its weight is acting downwards. Mg minus T is equal to M into A. So what is Mg? It is going to be 400 minus T is equal to what is the mass of it? 4 into 4. Sorry, 40 into 4. 40 into 4, which will be 160. So what is going to be the tension? Tension will be 400 minus 160. Answer will be 240 Newton. So this will be the answer. So this 240 Newton is given to us for us to understand if it is less than that 600 or greater than that 600. For example, if you have got the answer as 720, had you got the answer as 720, should you report that answer? What will you write? It will be 0. Tension will be 0 when it is accelerating downwards because it is greater than 600. So the string will not be able to withstand, it will break. So means the monkey will fall down along with a piece of string. So tension at that time will be 0. You should not write 720. Did you understand what I told you? So it is very important to have these points in mind. Shall I proceed? Yeah. Here. Try this. what is the answer? So linear velocity, you leave it. Can you tell me what is going to be the acceleration? Like, can you at least tell me what is going to be the formula? Correct. So it's V square by R because it's circular motion, no? What about the tension? Tension will be mv square by R. Anyways, leave this. I don't think you'll be able to relate it. Leave it. Next, try the seconds. What is the momentum of a 1 lakh kilogram truck whose velocity is 20 meters per second? So it will be 10 power 5. Actually, what will be the answer? So 20 into 10 power 5. So if you look at this problem, what is the momentum of a 1 lakh kilogram truck whose velocity is 20 meters per second? So momentum is 10 power 5 into 20, which is going to be 2 into 10 power 6 kilogram meter per second. So since we have only 2 into 10 power 5, the answer will be none of this. Okay. 15th question. A ball strikes a bat with a velocity v. Okay. The ball has a mass m, and after striking it, retraces its path. What is the impulse imparted by the bat? I've solved this problem in the class. So if you take the bat to be like this, right? The ball comes and hits with a momentum of mv, and it rebounds with a momentum of the same mv. Right? Then what is going to be the change in, what is going to be the impulse imparted? Impulse is equal to change in momentum. So change in momentum will be, if you take towards as positive, so it will be mv minus, backward will be negative, so it will be minus mv. So answer will be 2mv. The most common mistake that is done is 0. 0 is not the answer, it is 2mv. Okay, and this is an important problem also. If you recollect, impulse is actually the change in linear momentum. Okay. Done. So I'll do this problem. Listen to this. A stone is dropped from a height h. It hits the ground with a certain momentum p. Okay. So there is a stone which is dropped from a certain height, and it hits the ground with a momentum p. So this height is h. So what is the momentum with which it is going to hit? P will be equal to m into, what is the velocity when it is having a free fall and going to touch the ground? It will be root of 2gh. So it is simple, okay? All that you need to apply is v square minus u square is equal to 2a is v is what we need to find. V square minus 0 square is equal to 2 into g into height is h. Okay. So 2 into g into h. So v will be equal to square root of 2gh. Is the point clear? So v will be square root of 2gh. Let this be equation number 1. Now what did they say? If the same stone is dropped from a height 100% more than the previous height, when they say 100% more than the previous height, what will the new height be? H plus, it is not 100 meter, 100%. H plus h. So the meaning of it is the new height will be h plus 100% means 100 by 100 into h. Both cancel, h plus h is 2h. So that is the meaning. So if I take p dash to be the new value, that will be the object is going to have the same mass, but the momentum will be square root of this time. What is changing? H is becoming 2h. So 2h means it become root of 4gh. So root of 4gh means how much is it going to be? It will be 2 times m into root of gh. Okay. Now if you see, the momentum when it hits the ground will change by what factor is what they're asking. So when you want to calculate this percentage change, right? So percentage change is given as final minus initial divided by initial into 100. Final minus initial divided by initial into 100. So final is how much? 2m root gh minus initial is m into or root 2m into root gh, the whole divided by root 2m into root gh into 100. So what will happen is root gh will cancel everywhere. M will also get cancelled. So what are you left out with? 2 minus root 2 divided by root 2 into 100. So 2 minus root 2 means, so basically if you rationalize it, no, it will be 2 root 2 minus 2, the whole divided by 2 into 100. So if I rationalize it, 2 root 2 minus 2 divided by 2 into 100. So 2 will get cancelled here. 1.41 minus 1 is 0.41. So 0.41 into 100, how much is it going to be? 41%. So is there an option? This one. So it will change by 41%. Is the point clear? Are you writing? So it will be 41%. Clear with this? We're done copying? This is from yesterday's concept. The coefficient of friction between the tires and the road is 0.1, mu is 0.1. Find the maximum speed allowed by the traffic police for cars to cross a circular turn of radius 10 meter to prevent an accident. So V is equal to root of, check your notes, you will get that, mu RG. So mu is 0.1, R is 10 into G is also taken as 10. So 0.1 into 100, root 10 will be the answer. So the 17th question says, the coefficient of friction between the tires and the road is 0.1. So mu is equal to 0.1. Find the maximum speed allowed by the traffic police for cars to cross a circular turn of radius 10 meter to prevent accident. So V will be equal to root of mu into RG. Right, this is the maximum speed. So root of mu is how much? 0.1. R is 10. G also you take it as 10. So 10 into 0.1 is 1. So you're left out with root 10 meter per second, and this will be the answer. Okay. Done. So this is based on the first problem. Do it fast. Right. So in this question, again, it is based on the concept of apparent weight. So it says a man of mass 75 kilograms is standing in an elevator which is moving with an acceleration of 5 meters per second in upward direction. So the apparent weight of the man will be. So apparent weight is equal to, in this case, what will happen is you write the mass of the man. So basically, what is the weight? It is mg, no? Mg would have been the weight had there been zero acceleration. But since the acceleration is upward, you will take the pseudo force in the downward direction. So it will become G plus A. It will become mg plus ma, that I took out m outside. So m is how much? 75 into G plus A will give you 15. So 75 into 15 is 1125 Newton, and A will be the option. Okay. Those who are online are able to understand?
Yes, sir.
Yes, sir.
Okay,
Yes, sir.
good. Done. What is the time? We'll just do 2 more problems. Yeah. So the 19th question is, according to Newton's second law, the momentum of a body is directly proportional to the applied force and takes place in the direction of application of force. The integration of the momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. The momentum of a body is directly proportional to the applied force and takes place in the direction opposite to the force, or the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Which one is right? D is the right answer. That's what the statement is. F is directly proportional to the rate of change of linear momentum. So on solving this rate of change of linear momentum only, you will get F is equal to ma. Okay. Clear? So this problem says, an object of mass 10 kg lies on a rough horizontal surface. When a horizontal force F Newton is acts on it, it gets an acceleration of 5 meters per second square. And when the horizontal force is doubled, it gets an acceleration of 18 meters per second square. The coefficient of friction between the body and the horizontal surface is going to be how much? So it's very simple. there is an object of mass m that lies here. So mg is acting downwards. In the first case, so let's say there is a horizontal force applied like this, right? And there is going to be a frictional force acting in the direction opposite to it. So what is this frictional force given as? F is equal to mu into n. So this is going to be n, and what is going to be the acceleration? So first case, it will be 5 meters per second square. In the second case, it will be 18 meter per second square. So what is the equation you are going to apply? Capital F minus small f is equal to m into a. Is that right? So capital F is not given here. And the force of F Newton is what is told. F minus, what is going to be the frictional force? It will be mu n, which will be mg is equal to m into a. Now, if the force is doubled, so this F becomes 2F minus, what is going to happen to the frictional force? It will have the same mu and same mg. The normal is not going to change because the mass is same, is equal to m into a dash. So here, what is m into a? It will be 5m. Here, what will be the value? It will be 18m. Am I clear with this? Right. So what are the data they need? They need us to calculate the coefficient of friction. So what we'll do is, we'll multiply the first equation with 2 and then subtract both. So when I multiply the first equation with 2, this will become 2, 2, and this will become another 2. So what will happen here? 2F minus 2 mu mg is equal to 10 times m, subtract both. When you subtract both, here it will become minus, plus, and minus. So 2F and 2F are gone. Minus mu mg plus mu mg is, sorry, plus 2 mu mg is, mu mg is equal to 18 minus 10 is going to be 8. Right? This implies mu into, what is the value of m? It is 10, and acceleration due to gravity is taken as 10 is equal to 8. So what will be the value of mu? 8 divided by, 1 minute, it is 8m actually. So it is 8m means it is going to be 80. So it is going to be 80 divided by 100. It will go 4 by 5, it will be 0.8. So answer will be 0.8. So 80 by 100 is, you can directly write it. 1 minute. So observe. What I'm doing here is, it is going to be, mu will be equal to 80 divided by 100, which will be written as 0.8 directly. So 0.8 is the answer. I hope you could understand, right? So it's actually a simple problem. The reason why they have given two conditions is because there were two unknowns. Because if you see, for mass, they have given a number, for acceleration, they have given a number, but for force, they didn't give any number. So this question can be extended in such a way that they can ask you what is the force in the second scenario. If that is the case, since you know mu here, take this, substitute it here, calculate 2F, don't calculate F, because the force in the second case is 2F. Similarly, if they ask the force in the first case, you will only write F. So need to be careful with that. Okay. Okay. So let's stop with this. There are 5 more problems, but yeah, you can stop with it. Similar kind of pattern. So remaining ones, you can try it out from your textbook itself. So those are online. Any questions?
No, sir.
Okay. So we'll wind up. Okay, those are online, you can leave. For math class, you can join by 6:05.
Okay, sir.
Okay, sir.